Hi Math 2. This is Unit 7, Lesson 3, and I'm on page 168 of our workbooks. So Lesson 3 is on tangent lines, so let's discuss what a tangent line is. Somewhere on the circle on page 168, place point A. I'd like to draw a line through this point A that touches the circle only one time. So very carefully, draw a line that goes through A and touches our circle only one time. This is called a tangent line. A tangent line means that the line touches the circle only once. We say that point A is the point of tangency. So point A is the point of tangency. So something interesting occurs at this point of tangency. If I connect a radius from O to A, if I connect a radius from my center to my point of tangency, I always have a particular type of angle. Are you already noticing what type of angle must occur there? On this line, I always have a 90-degree angle at the point of tangency. So the radius and the line tangent are perpendicular at A. Remember, perpendicular would be our 90 degrees. This always makes a 90-degree angle. So where our radius touches our line tangent is always a 90-degree angle. So let's take a look at a math problem that has this set up. On the next page, let's take a look at this Are You Ready for More diagram. So we're going to calculate the length of AB. It says to find the length of AB, and we're going to use trig to do this. So one thing I'd like to note, if you don't have a scientific calculator at home, go to your iPhone or whatever phone you have, and generally if you go to your phone's calculator, so if you go to the phone calculator and you turn it on its side, you should see a lot more keys to your calculator, and on those keys you should see tangent, sine, and cosine, which we're going to use. You should always also see the square root symbol, and we're going to be using that today in a problem as well. So if you don't happen to have a calculator at home, you should be able to use your phone calculator to access some of these functions that we need. So let's take a look at this problem. Here is circle O, and I've got AB as a line tangent. So I know that point A is my point of tangency. So my radius, OA, and my line tangent AB form a right angle. So that's pretty significant because that's what's going to allow me to find my AB for number 1. So in this problem, to use my trig for my 50-degree angle, this is my side opposite, this is my side adjacent, and OB would be my hypotenuse. So it looks like what I have here is opposite and adjacent, and going back to my SOHCAHTOA, opposite and adjacent is tangent. So I could write that tangent of 50 degrees is equal to my opposite side, which is AB, over my adjacent side, which is OA, which is 1. So I'm going to multiply the 1 over. Technically, that doesn't do anything because it's 1 times something. So it looks like my AB is equal to the tangent of 50. So grab your phone calculator or your scientific calculator and calculate the tangent of 50. As long as you're in degree mode and you've hit your buttons correctly, you should get 1.19 for your distance of AB. So let's look at another type of problem that we sometimes see with these tangents. So down here at the bottom, let's do another example, math problem. Let's go ahead and draw another circle. Have your center be O. Put your point A on the circle. Draw your line AB that's tangent. So very carefully, I'm going to draw a tangent line. Put your point B on it. Connect O to B and connect O to A. This creates my triangle that I'm going to be using. Okay, so this time let's keep our radius at 1. And I'm going to tell you what the distance from A to B is. The distance from A to B is going to be 3. So in this problem, I would like to calculate, let's call where OB intersects the circle, make that a C. Ultimately, ladies and gentlemen, I'd like to find the distance of CB. So that's what I'm going to be looking for. So let's start looking at some things that I can do with my problem. So first of all, the major point I'm supposed to have learned in this first page or two is that where my tangent line touches my radius, I have a right angle. So let's put my right angle in. And in this problem, that makes OAB a right triangle. So besides trig, something else I did with right triangles was the Pythagorean theorem. So in this case, I know that the Pythagorean theorem, a squared plus b squared equals c squared, works for this right triangle. So in this problem, my OB would be my hypotenuse. This would be my c squared, because this is across from my right angle. So my sides that are 1 and 3 are my A and B. So I know that 1 squared plus 3 squared is equal to my OB squared. So 1 plus 9 equals my OB squared. So 10 equals OB squared. So now let's take the square root of both sides. So grab your calculator, take the square root of 10. You should get approximately 3.16 or 3.2. Either answer is okay. So that's the entire side OB would be 3.2 or 3.16 units. So if my radius is 1, notice my radius was 1, then my distance from O to C would also be 1. So in this case, I can now find CB. CB would be the total distance of 3.16 minus the part I know of 1. So it looks like from C to B is 2.16. You might say, well, it doesn't really look like that. I would agree with you. This picture, we like to say in geometry, is just not drawn to scale. And that's how we have to depend on our math instead of what the picture looks like. Okay, ladies and gentlemen, let's go to the next page. So this is another picture that we often see with tangent lines. There's going to be 2 tangent lines, and we have our third type of angle that I'd like to talk about. This angle Z is called a circumscribed angle. And a circumscribed angle is outside the circle. And just like a central angle and an inscribed angle, it has a special relationship with its central angle. This is made of 2 tangents. And in this problem, we're going to find that it is supplementary with its central angle and or its arc. So let's take a look at this activity so we can understand that. Go ahead and put on your 2 points of tangent C, and let's connect it to the center. So we're going to connect it right here. This diagram we often see, and let's call this W. So 2 things for you to learn from this. First of all, these are our points of tangency between the radii and the line tangent. So I know they're both 90 degrees. So in this problem, this is a quadrilateral. So I know that my four angles should total 360 degrees. So if I have 90 plus 90, which is 180, that leaves my central angle W and my circumscribed angle Z to also equal 180. That's what it means to be supplementary. It means that it's going to add up to 180 degrees. So let's look at a math problem using these two. So another example. So let's draw our circle and let's put on a center A. We're going to draw two tangents. So draw a tangent line on top, and we're going to draw another tangent line that meets at the same point. So draw a tangent line on the bottom, and you have your 2 points of tangent C, and I have where they meet. So let's call where they meet B, and let's call my first point of tangent C on top F, and my point of tangent C on the bottom E. Finally, let's draw in our radii A to F and A to E. And in this problem, let's go ahead and draw in our right angles. Point F is my point of tangency between my tangent line and my radius, so it's going to create a right angle. Point E is my point of tangency between my radii and my line tangent, so it's going to be a right angle. My drawing is not perfect, but I do know that mathematically, if those are tangent lines, they're going to create a right angle. So before I go any further, I'd like to remind you guys, since it's a quadrilateral in this picture, my measure of angle A plus my measure of my angle F plus my measure of my angle B plus my measure of my angle E equals 360 degrees. That's how I'm getting to the fact that A and B are going to be supplementary. So let's take a look at giving a measurement here. Let's say FAE, my central angle, is 120 degrees. Okay, great. And I want to know what my angle B is. So I want to calculate that. So I know that all four of these measures add to 360. I could use that, or more specifically, I learned up above that my central angle, so that's my 120 degrees, plus my circumscribed angle, my measure of my angle B, has to equal 180. So therefore, subtracting 120 from both sides, I know the measure of angle B then would have to be 60. I know a few other things in this picture, by the way. I know that this arc from E to F, I know that that's also 120 degrees. So this picture could have looked a little different. I could have drawn the circle, and I could have not drawn in the radii at all. I could have just drawn the two lines tangent with B, and then I could have told you that the arc is 120 degrees. It is true that the arc and angle B are also supplementary, so I could get my 60 degrees in that manner too. Just another way that you sometimes see the algebra using these circumscribed angles. On this page, the big takeaway was that I learned that circumscribed angles are made up of two tangents outside the circle, and that they are supplementary to the central arc. The central angle or the arc. So taking a look at our next page, our summary. This is my line tangent. L is my line tangent. B is my point of tangency. So L is my line tangent. B is my point of tangency. And we know that this creates a right angle. So B would be a right angle on both sides. So I'd like to review the types of angles that we have learned so far. So the types of angles. In lesson 1, we learned about central angles. So central angles, as a reminder, has their center has the vertex on the center of the circle. So a central angle has its vertex on the center of the circle, and it is equal to its arc. So then the second type of angle we learned was an inscribed angle. Inscribed angles had their vertex on the circle. So An inscribed angle has its vertex on the circle. And the special relationship for an inscribed angle in its arc was that it's half of its arc. So this would be 35 degrees. And this third angle that we've learned is a circumscribed angle. The circumscribed angle is made up of two tangents. And it's made up of two tangents, and I know that it's supplementary to its arc. So if the arc was 110 degrees, for instance, I know that my angle is 70. And if I drew in my central angle and I made that angle with the radii to the points of tangency, it's also 110 degrees, the same as its central angle. And then another angle that we learned today, without a specific name, but this is where I have my point of tangency. So where a radii touches my point of tangency is always going to be a right angle. So this was my point of tangency. And at my point of tangency, I always have a right angle, a 90-degree angle. Thank you.